Good afternoon, we're GeoDudes, and today we'll be presenting the Vision Learning smartphone application. Our team leader and requirements analyst is Madison Lafwan-Olmsted. Marnell Del Rosario is our database specialist and requirements analyst. Ben Tron is our software architect and software designer. And I'm Tim Cahoman, our technical writer and software architect. Our advisor is Dr. Boris Kovalchuk, professor of the Department of Computer Science. Our client is Dr. Ann Ager, assistant professor of the Geological Sciences Department. Our outline will consist of the following. I will be presenting the project overview. Marnell will be presenting the design and statistics. Ben will be discussing the debugging and testing section. And Madison will be demonstrating the application and concluding the presentation. The initial, in terms of the real-world problem, the initial application from visual learning was only available for iPhone users. Access was limited to the iPhone, and there was a need to reach Android users. Students and educators needed a portable smartphone application in the field. In addition, the current application lacked interactive features. The solution was to design the application that would be accessible to Android smartphone users and provide interactive features to facilitate learning and improve the user experience. The purpose of the software program is to create a Vision Learning Science Glossary smartphone Android application for the Central Washington University Geological Department. Dr. Ager requested the software program to allow Android users access to the Vision Learning Education Glossary. This application encompasses the basic functionality of the existing application with additional features. These additional features include an interactive flashcard study tool and a crossword puzzle. The initial plan was to develop the additional features for the iPhone application. However, the original iOS application was deprecated and not up to date with the current SDK. We rebuilt the science glossary in Objective-C, but due to time limitations, we did not add the additional features in iOS. We discussed this issue with Dr. Ager, and the project requirements were changed. The priority was to develop the Android application, and Vision Learning will update the iPhone application based on our conceptual model. Okay. For our first iteration, we developed a prototype on the Android platform similar to our existing iOS version. The second iteration consisted of the development of a flashcard component and adding search functionality to the glossary of terms. The third iteration involved the development of a crossword puzzle and an add terms activity feature. For the fourth iteration, we polished and prepared the application for publication. Marnell will now discuss the design and statistics.
The components involved in our project are different for both versions. For the Android version, the languages that we used were Java and XML. Java was mainly to control the activities that are going on in our application, and the XML is for the many layouts that we've generated. The programming environment that we worked on for the Java version is Eclipse with the Android development tools. For the iOS, we programmed in the language Objective-C using Xcode IDE. For both the versions, we utilized the SQLite database to store all our terms and definitions. On the right is an image of some of the components, mainly Java. On the left-hand side is what our team worked with for the Java version, and the right side is what was provided to us by the third-party Vision Learning, aside from the iPhone hardware, which we used our own hardware for that. And the middle is the SQLite database, which was provided to us by our client. Originally, We designed the iOS glossary on the Android based on the concept from the current version, currently in the iOS market, iPhone market. But then we used that concept and we built from the ground up using Java and the tools. We built that same exact glossary for the iPhone or Android platform. User design. The main motivation behind the design for all our interfaces was ease of use. We wanted the user to be able to go through all the activities without having any problems or having difficulties running through the different activities, which we will demonstrate in a little bit. But also at the same time, we wanted our application to appeal to the current users of the iOS and also attract new users for the Android application. We believe that our final designs for most of our views, or for all of our views, meet both those requirements. The image displayed in front of you is the view for the newly added activity, which is the add terms activity, which we will demonstrate. It consists of only 2 edit text boxes and 2 buttons in the bottom. We've also customized the buttons by adding images to them to make our application look better, but also to give somewhat description of what the button is doing. For example, the save entry has an image of a disk to save terms inputted by terms and definitions inputted by the user. Code statistics. Our Java version has 29 total classes, about 230 methods being used, which is roughly around 4,000 lines of code. Also, because our application is a smartphone application, it involves a lot of views and layouts. So we have a total of 28 XML layouts, which is roughly around 1,500 lines of code. Database-wise, we use a total of 26 SQL queries to both insert, delete, update, and select from our database terms. Now, next, Vintron will talk about our debugging and testing.
For debugging, so we encounter a lot of issues, but luckily those are mostly minors. For example, like code is not incorrect and incorrect helper methods, and layout doesn't display right, or memory leak. And it's actually easy to fix, and we only use the debugger and the log system to figure out what's going wrong. And yeah, so we just fix as they arise. For testing, as you know, we are doing both white box testing and black box testing. For white box testing, there are 2 aspects. We do unit testing, which implement the JUnit, the extended version of JUnit for Android. And these are mostly used to test the database helper methods and the crossword data. And the other aspect of the white box testing is GUI testing. So we use the hierarchy viewer and layout objects to optimize the layouting of the application to make it as far as possible on the phone. For black box testing, we install the application on several Android phones from our friends and our co-workers, and after that, just have them run and experience the application, and then we collect feedback from them. So this is another screenshot of the hierarchy viewer of the crossword. So what you see, there's a lot of boxes presenting the grid view. So with this one, you can actually see every element that presented on the screen at the moment. So we're using that to check each of the activities. We're also conducting a segment testing, which is completed before the end of each iteration, and is conducted by the client. So basically, we just give her the form of the application, the last version of the application, and collect feedback from her. next Madison will present the
Okay, so when we first started on the application, we're good with the layout that you're familiar with from our last presentation. The new entries to our application are the Add Entry button and the Crossword button, as well as some additions to the flashcard feature. Starting with the Add Entry button, we're presented with text fields to enter in a term and a definition, as well as two buttons on the bottom where you can save the term or view the current terms that are in the database. I've already added terms to the database, so we can just view that, but if it's empty, we're shown a toast that tells us that it's empty and it's not allowing us to enter blank space basically into the database. Viewing the terms just shows us a list, and clicking on any of the terms, we're shown the term as well as the definition that's saved in the database. We're also given the options on the bottom to edit the term or the definition, add a new term, or delete the current term in the database. Going back to the flashcard, we have added some functionality to it. We've enabled the feature to create a list of terms that you want to quiz yourself on or test yourself on, and are able to bring up that list and save that list, so you don't have to constantly be going back and remaking your list every time you start the application. I've already made a few lists in the science part of our glossary. The science and the user terms are separate. We didn't want to combine those together because we thought that the user might want their terms separate from the science glossary. Clicking on one of the playlists or the lists that are in the database right now, we're shown the words that are currently in that list, and you can either continue on to the flashcard or delete that list. Creating a new list, click the Create button, and this is pulling from the user defined list. We have the checkboxes on the side. As you check them, the checkbox lights up, so you know which ones are currently selected. And clicking the Add brings up the notification that the user has to enter in a name for the list. And it's saved, and we're shown the flashcard view that we had shown before. Click on the flashcard, it shows us the definition, and we click the buttons on the bottom to indicate that you either know or don't know the word. And this is all similar to our last presentation. So going back to the crossword feature, this is the big feature that we implemented for this iteration. Clicking on the crossword, we're presented with two hard-coded views for the crossword. We currently have two. It took kind of a lot of time to develop those, so we only had time for those two. As you want to enter terms, you click on the box, and we'll start here. And if anybody would like to help me out in answering this crossword, the suggested hint on the top for 13 down is the uppermost 5 to 7 kilometers of the Earth. Let's go with bacon.
It's the crust.
Okay, so let's try crust. Gotta make sure the down button is going down as you're typing in. Okay, and then to check if that is correct, we hit that check result. And it shows lights the text box into, or highlights the text box to green if it's correct. Just randomly putting in letters and hitting the checkbox, it's red. We're also able to use a reveal feature, which is kind of to help you kind of get started with the word. So if we click the reveal button, it tells us the first letter in that word is a E, which is really hard to see. It's not focused. No. And that concludes our crossword demonstration and the demonstration of our application. So what we learned from developing this application is both development on the Android platform as well as we started developing on the iPhone platform and learning kind of what tools that had to offer before we were told we didn't have to continue with that. We also learned extensive GUI development. Previously, we never really dealt with that, and it was one of the harder things that we had to do is develop GUIs for each activity that we used. We also were utilizing databases on the smartphone, which obviously we'd never done, and we had never really had that much experience with the amount of queries that we had to use. Post-mortem, we completed the client's requirements to this point, and had all the interactive features that the client requested. And for the next week, we stepped through our final testing, as well as comment the last couple of classes, as well as complete the documentation. That concludes our presentation. Are there any questions?
So thinking into the future, you all are graduating either this quarter or next, but I'm sure the application is going to live on. They're going to want to make changes, add more crossword puzzles, that type of modifications and enhancements. And what types of things did you do to enable future developers to be able to make changes?
So we actually have a structure of the crossword data. So basically, the user just have to make a string, and it's going to be inputted into the application easily. So it's just going to be a string of the term and then the information of the term. And then it's going to be automatically calculated into the...
So you built a tool then to be able to create crosswords,
Yes,
is what you're saying?
Yeah.
And what types of coding standards, commenting standards did you include with the code to...
Right now, we're not sure about that, but we have to see the documentation first.
So, did you say the crossword puzzle was static?
Right now, we only have two data.
Well, the thing that it's using is the user has to generate the data from by themselves and just input it into our one of our classes, and it'll automatically calculate which is being which is like in what position. The first letter is on like what box, what column, and everything like that. So yeah, it kind of took a while to do that also. And like which orientation the word will be displayed in.
So the puzzles are generated automatically?
Not.
No.
It's like the user gonna have to design the crossword puzzle first. Yes, and then it's gonna be generated to a string through there.
So what you're trying to say, it's not, you can't just give it a bunch of terms and
No.
letters and it won't.
It takes a long time
That'd be really
to do
cool.
that.
And one of the reasons we didn't want to do that is because in a lot of the terms, the actual answer is in the definition, so we would have had to either shorten the definition, which might not have been enough of an explanation.
So what we did is we went into each of the individual definitions that we used for that crossword, and we grabbed what we thought was helpful for that term, and we just scrapped the rest and used that instead for class. So they have to do it manually. It's not being generated automatically. That's what you're trying to say.
So, I know you guys had to scrap this, but as far as the Objective-C developing environment, Xcode, assuming you were using Xcode 4, how did you enjoy learning Objective-C? Whoever worked with it the most?
We enjoyed it because we could implement the new storyboard component to it. I thought that was really exciting. And we actually wanted a demo today, but in our rehearsals, we didn't have time because we covered the full 20 minutes. But I think it's definitely something to continue to pursue.
Okay. Yeah. How did you enjoy the actual language, though?
At first it was hard, but like when you get used to it, it's really nice because the auto suggestion of the Xcode is really nice.
Yeah.
It suggests everything.
Yeah. And I discussed this with you guys earlier, but you told me there were problems between the storyboard and the original application. I can't remember what it's like an XLB file or something.
It's the XIV.
Okay. And I was told that you had some issues with kind of...
Yeah, so like we thought there was no storyboard and they used the XIV and they had to manually reference to the thing, not just like control drag and reference the button, something like that. Yeah. So, and besides they use like version of Objective-C, I think like doesn't include new data library.
I think the Xcode 3.2 would have been, or 3.4 I think what it is, would have been the one. So,
And the initial application was developed in 2009. As you know, the technology has advanced so much from then. And that might be a lesson for future programmers working on this as well, is that this is going to constantly change. And so this may need to be updated consistently.
So what happens when they have to update the iPhone version, though? What happens then? What do you guys have to do that? Or something, just theoretically? You don't have to answer that question. I'm just curious. We can talk about that later.
Okay, sure.
Okay.
There is a module to update the iPhone actually
Nice.
built into it. Yeah.
So,
But it connects to Vision Learning. I'm sorry.
So from your experience, let's assume that the next team of students need to really address that question of dating. How much time, starting from scratch like you started, you believe they would need to update your software?
I think it's usually based on when Google or Apple roll out the new firmware.
No, presumably significantly so. Let's say in half a year they will not dramatically change.
Yes.
So,
I think with the inclusion of storyboarding too, it changed the entire conceptual model used by Objective-C. And so if there's a drastic change like that, it would take quite a bit to actually, they may have to build it from scratch like we did. But if it's a marginal change, perhaps not.